Imagine an intellectual David versus Goliath battle, but with a seriously academic twist. Welcome to The Explainer. Today we're unpacking a wild case where a defendant, Dr. Chen Jingyuan, literally used complex statistical physics and network science to mathematically obliterate a legal charge against him. It's an absolutely fascinating collision between rigid legal frameworks and modern science, and we are going to break down exactly how he pulled off this defense.
So, to get our heads in the right space, think about this for a second. If you drop a single grain of sand and it triggers a massive avalanche, did you cause the disaster or did the mountain? That question is right at the heart of our case today. It tests the very boundary of causality. We're looking at whether one internet user's completely isolated retweet can actually, legally, be blamed for causing a macro-level disruption in public order. Like, how do we even define responsibility when the system we're talking about is already incredibly volatile?
Well, to really grasp Dr. Chen's defense, we first have to recognize that modern social media networks are textbook complex systems. They aren't simple, predictable machines. We're talking about millions of interacting components where the platform's overall behavior emerges totally unpredictably from localized interactions. Because of this, they're inherently nonlinear, meaning a tiny input doesn't necessarily equal a tiny output, and a massive chaotic output doesn't always need some massive input. But, as you might guess, the legal system doesn't exactly see it that way. In this case, the prosecution hit Dr. Chen with a severe charge, causing severe disruption to public order. And the crazy part? They pin this entirely on him making a single retweet on a social platform. The legal argument claimed a direct, purely linear link. They were basically saying this one isolated social media post directly triggered massive systemic chaos across the public sphere.
And right there, we hit the core paradigm shift of this whole case. The law traditionally leans heavily on a linear, Newtonian logic of cause and effect. In the legal mind, it's simple. A causes B. Complete order is just assumed to be the default state of society, so any chaos must be caused by a specific anomaly or a bad actor. Science, though, specifically complex system causality, argues that the structure itself dictates the response. Massive, distributed networks are, by their very nature, inherently chaotic and always fluctuating.
To actually prove this inherent chaos mathematically, the defense didn't just throw out theories, they brought in the CAP theorem. If you're into computer science, you probably know this one. It's a foundational principle stating that a distributed network literally cannot achieve consistency, availability, and partition tolerance all at the same time. You always have to sacrifice one. Because of that hard rule, social networks can never be perfectly orderly or fully consistent. A degree of localized disorder isn't a crime-induced anomaly, it's a constant, normal mathematical state. Building on that, the defense brought in scale-free networks, a concept popularized by network scientist Albert Laszlo-Barabasi. Social networks are scale-free. That means they are totally dominated by a few massive hub nodes. Think of your mega influencers or huge media outlets. Meanwhile, the vast majority of us are what you'd call fringe nodes with very few followers. It's an extreme power law distribution, which mathematically proves that not all internet users have the same structural power to actually influence the system. So where did Dr. Chen fit into this digital ecosystem? Well, with under 100 followers and barely any historical engagement, his account was the definition of a fringe node. Now, while a hub node has massive structural influence, where deleting it could legitimately make the system vulnerable, a fringe node is mathematically insignificant. You could literally delete thousands of fringe nodes at random, and the network's overall structure and information flow wouldn't change one bit. And here is the absolutely crucial point. According to Cohen's critical threshold formula in physics, the network has extreme robustness against fringe activity. This formula mathematically guarantees, that the actions, or even the complete removal of a fringe node, simply cannot destabilize the whole structure. It is exactly like tossing a single pebble into the ocean. Sure, the pebble makes a splash, but it absolutely does not cause a tsunami. Now, you're probably thinking, okay, but what about going viral? We've all seen absolute nobodies suddenly blow up online, right? So if a fringe node retweets something super controversial, couldn't it act as the spark that triggers a huge information cascade? To answer that objectively, the defense argued that we have to put our intuitions aside and actually look at the math of extinction to see how an individual post spreads in reality. To measure this, they use something called the Galton-Watson branching process. Think of it as a mathematical model to predict cascading propagation, kind of like tracking how a virus or a rumor ripples through a population. The whole engine of this formula is a single variable called m, which is just the expected number of subsequent shares generated by one post. It's pretty straightforward. If m is greater than 1, the cascade grows. If it's less than 1, it's mathematically guaranteed to die out.
When you look at these specific parameters of Dr. Chen's account, again, under 100 followers, practically zero interaction, the M value was estimated to be a microscopic fraction. We're talking about an expected share rate of roughly 0.02. In physics, that puts his action in a deep subcritical state. With an M value of 0.02, the spread has to die out almost instantly. Statistically speaking, it's practically impossible for an account with that profile to sustain a system-wide cascade. When we actually map out these probabilities, a fringe node retweet has effectively a 0% chance of causing a systemic event, all on its own. For an actual avalanche to happen, you either need a massive hub node to push the information, or the entire system must already be in a state of extreme criticality. Random micro-perturbations from tiny fringe accounts, they just don't drive systemic avalanches. Which brings us to what the defense called the final straw fallacy. If a macro-level disruption did happen, like the prosecution claimed, we have to ask why the system collapsed. The law is always looking for the last straw that broke the camel's back, but statistical physics uses the Fluctuation-Dissipation theorem to explain exactly why that camel's back was so incredibly fragile in the first place.
The Fluctuation-Dissipation theorem, or FDT, maps this out beautifully. It shows that when a microperturbation, like a tiny retweet, hits a system, the system's internal structure dictates the response. If a massive avalanche results from a tiny input, FDT proves the system's internal response function was already highly unstable. Basically, the system's temper was already primed to explode. The trigger itself is practically irrelevant.
The defense doubled down on this using physicist Perfact's concept of self-organized criticality, or SOC. This theory suggests that complex systems naturally evolve over time to a highly unstable tipping point, completely on their own, without any central coordination. So if an avalanche occurs, SOC tells us the root cause was that the entire network had already reached a critical breaking point long before any single user did anything. It's the critical state that's to blame, not the last snowflake to fall.
Ultimately, the defense highlighted a profound mismatch in logic here. The prosecution was leaning on this linear assumption that a microperturbation directly and solely caused a macro collapse. But the statistical physics model proved that systemic criticality created the collapse, and the microperturbation was really just statistical noise. The legal system was basically trying to judge a quantum-level complex network using 19th century Newtonian logic.
As the source material puts it so perfectly, this defense was a dimensional strike of science against arbitrary legal power, ensuring truth is not permanently overwritten by power narratives. It's such a paradigm-shifting reminder that the rigid, super-linear structures of the law are eventually going to have to reconcile with the mathematical and structural realities of modern tech, because at the end of the day, you just cannot legislate away the laws of physics.
So, we circle back to where we started, but hopefully we're looking at it with a much deeper perspective now. As our world turns into this incredibly vast, intertwined, complex system, who is truly responsible for an avalanche? Is it the last snowflake or the deeply unstable mountain? Thanks for joining this explainer, and definitely keep questioning the frameworks that shape our reality.